Okay, hi everyone. Welcome to my talk. It's on interfacing with Azure queues, which I think will kind of go hand in hand with the system link stuff that we saw today. But I'm pretty new to system link, so I'm just going to show you what I know about Azure. For some context, so my name is Alex and I'm from Software Systems. You've probably seen or heard from us today already. I have about 2 years experience with LabVIEW, so it's just really close to the double digits that most of you probably have in the room. And then in this talk, I'll be explaining basically what an Azure queue is and how to interface with it in LabVIEW. Let's get started. So Azure queues are part of the Azure storage platform, and they're all connected. They would be connected to a storage account. And basically, a storage account is the part that provides the secure storage for your data objects in the cloud. Alongside Azure queues, you'd find stuff like blobs and tables, which I'm only really mentioning here because what I'm going to show you today, if you've maybe heard of those or need to use those, you could use the same thing, like the toolkit I'll show you today, with those items. Okay, so what is an Azure queue itself? Basically, it's a service for storing a large number of messages. Each message is up to 64 kilobytes in size. And then depending on the storage account that you're connected to, you could have up to 1 million messages up there waiting if you wanted to. So the messages are pushed to the queue by a sender, and that's done with usually a HTML request, or you can do it from Azure itself, or you'll also find that you could do it from your LabVIEW application if you wanted to. And basically, when messages are pushed to the queue, they'll kind of sit there until they are accessed. But they do have a default expiry time of 7 days, but otherwise they can exist there for a while, waiting for the receiver to be ready. So that means even while the recipient is offline, the messages will still exist, and then they will be there when the recipient is online and is ready to start using the messages. And the preferred protocol for interacting with Azure queues is HTTPS, and then all the access to the endpoint is secured by default with Microsoft managed keys. So Microsoft is kind of taking care of the authentication that you might require. Cool. So Azure queues and LabVIEW. I think maybe one of the main things that queues would be useful for is allowing applications to work asynchronously. So it's great for reducing the risk of errors that might happen with latency or network issues. So in that case, it would kind of be a great tool for communicating between an online database and your LabVIEW application, especially because it's like an Azure embedded service. You can communicate to your other Azure objects. And another thing would be maybe from the LabVIEW side, I mentioned that you could be a sender as well. So you could use that queue and push messages there to send data back to the cloud. And I think the main thing here with Azure queues is if you're kind of someone like me who doesn't have a lot of cloud experience, or maybe it's something that your customer really has Azure and you need an easy way to sort of get that communication started, queues would be like a great starting point. And I had little to no experience with this kind of stuff, and I was able to work it out. So hopefully you guys would be able to as well. And then luckily, we have a whole toolkit available online. And this sort of interfaces with the blobs and tables that I mentioned before, so a bunch of Azure cloud services. And this toolkit implements the most basic Azure API that kind of provides enough functionality to get started. So if you can see, there are some VIs here to get messages from the queue, and also there's that functionality to in-queue messages. And there's also a few things there that maybe you can have a glance at and see if anything catches your attention. But mainly when I've used it, it's to pull messages off a queue. So what's great about the toolkit is that you'll basically just need the storage account name that I mentioned earlier and that key, and you're basically ready to get started pulling messages or sending messages or interacting with the queue. And also it is open source, so if the functionality there isn't enough, it should be easy enough to sort of implement or grow on it further. And one thing I did find when I was using the toolkit was that it only supports authentication by that storage account key. So if you wanted to do something like SAS tokens, which our cloud engineer was super keen on, you kind of have to build on it a bit more, and it won't be there right off the bat. Okay, so we have a toolkit. Let's kind of get into a quick example of how you might build an application around the service. I've just got some examples here, so just to make it really clear how easy it is to get started. So on the top, we can see opening a session. I've kind of unbundled what the credentials you need would be, and it's a storage account name and an access key. And that's kind of what you need to start, what the toolkit uses to start querying to get information from a queue. And then here's just an example. If you were getting a message, the type of stuff that you can get, the type of information that you can pull from the VI, and then sort of use that to do certain things in your application or react to messages a certain way. Awesome. So I've got up here a classic producer consumer loop, because I am from software systems, so we know that's what we use here. So this application on the top left, sorry if it's a bit hard to see, but I'll have some pop-ups soon to make it a bit more clear. So top left, we have our Azure queue producer loop that will be monitoring the Azure queue. Producer 2, general event structures so that we can have an interactable application. And then we've got our consumer loop that will be reacting to the overall queued messages within the application. Okay, so in general, to get started, we have here open Azure session. You do this like when you initiate your application, and you're just providing that storage account name and the key. Then in your loop, you monitor the Azure queue. That's done by, in the while loop, sending the HTTPS request. And then there is some logic in that VI I have there that takes the get message VI. There's a few things to check if there's a message or not, and if there is, we will enqueue an event. We'll enqueue an element, and then down the bottom in our consumer loop, we dequeue it, and then we can do whatever we want with the data. It is mainly text-based, so you sort of have to deconstruct the string from there. But I guess the idea is it can work in parallel with other loops, which is really great. And yeah, basically receiving the data. I don't have a demo, but it's really awesome. You send something and it pops up. So that's basically what happens. And then just to like wrap things up, because now we have a general idea of how they work, and it is test system day. So I wanted to tie it in a little bit. Generally, like I think one way to do it to really simplify, because it is so simple, is like just pushing test results to the cloud, like your pass, your fail, or a numerical value or something like that. Or in one instance where we've sort of used it is with serial numbers. So you could either, like, if you had one station creating serial numbers and they would be pushed to maybe another application across the production line, you'd be able to use a queue and all the serial numbers will be there waiting while the receiver application can obtain the messages as they like or all at one time, something like that. So they'll sit there until they can actually be used by the recipients. And that's all for my lightning talk. I hope you guys enjoyed it. I think like from a starter perspective, I'm new to LabVIEW. I'm new to Azure. It's kind of like a small, simple feature that like I enjoyed using, and hopefully you guys it might be a bit of an introduction to Azure services and other things like that in future. So thank you.